Hi, in this tutorial I will give you more details regarding the block execution order. If you know any textual language, you already know this concept. In a textual language, it's more intuitive. The execution order of the statements is from top to bottom. While in a graphical language like this, is not so. It's not from top to bottom, left to right, or something like that. It's defined by the numbers. But the main question is, but how is possible that so far we never take care of the number, and the strategy worked well. The cooling start-stop when we expected, hitting the same, and so on. But why now, with this strategy, there is the problem with the block execution order? The point is that since the blocks are executed one after the other according this number, after that the program restarts from the first, happen that sooner or later all the blocks returns the correct value. So this block sooner or later will make the difference between this value and returns the correct value. And sooner or later this block is executed or will be executed, and so it will returns the correct value of the stage. And sooner or later this block will be executed, and so on. So for, I would say, the most part of strategy, this sooner or later works. There are some side effects that I will show you later, but works. But there are other strategies like this where the sequence is critical. In this strategy, if this block is executed before others, can't work. I told you that in both languages, textual and graphical language, all the blocks or statements sooner or later are executed because they are executed continuously. Once reached the last block statement, the cycle restarts from the first. I mentioned before that there are some side effects regarding this issue. I prefer to show this with this example. Let's imagine to have a simple program, textual program, like this. I initialize two variables and then make the addition of them, the sum of them, and then print the value somehow, and then restart. Okay, I can write a similar code like this: b equal 5, a equal 1, c is addition, and so on. So there is a difference between these two strategies or not? Okay, no difference. For this reason, there is the smile, because it doesn't matter if we initialize b before a. The important is that before this statement, A and B have the correct value. In this case, the initialization value. What about the example number 3? Example number 3, there is as a first line the sum of the two values, and after that the initialization, and then print, and then restart. Is this program correct or no? Works well or no? Here there is a red sad smile, because what happened is this. When program starts, it executes the addition a plus b, but the value of a and b, since they are not yet defined, the value are 0. So c take the value 0. This line print c, that is 0, and then program restart. But now a and b have the right value, so c will be 1 plus 5, so 6, and so this line will print 6. So this code is not so bad. It's not perfect, ideal. It's not so bad because sooner or later you will print the correct value, that is 6. In this case, you will print the correct value after one program cycle. What about the last? You see that in the last, I place the statement in the opposite, complete opposite order. So start the program, print C. C is not yet calculated, so it prints 0. And then C is the addition, but since I have not yet initialized the variable, C is 0. And then restart. C is still 0. Now C takes the right value, that is 6. Third program cycle, C has the correct value, and so it prints correct value. So you can see that in the first two examples, there are no problem. In the first program cycle, the system prints the correct value. In this example, we lose one program cycle. In this example, 2 program cycles. And you can imagine that if the code is long with 50, 100 and so on lines, where the statements are in the not ideal order, you may lose 2, 3, 4 more program cycles. If you consider that in a real application, in a medium speed controller like a Pico 3, the program cycle is about maybe 300 milliseconds. So if you lose 2 program cycles, you will have a delay of 600 milliseconds and so on. So imagine that instead of to print something like this, you manage the safety of the compressor. For example, the compressor overload. So if the strategy regarding the compressor overload is in not the correct sequence, you may lose 1, 2, 3 or more program cycles, and so when the overload switch opens, the compressor would be switched off after not in the same program cycle, but after maybe 1 or 2 or 3 or more seconds. This is not good. Okay, even if in this specific case the safety of the compressor are also included in the electrical say control of the contactor compressor. Anyway, it is not good. So the message, in short, is when you place code, always take care of the sequence. So also here, when you place the code, the blocks in this case, sooner or later, we have to take care of the numbers. So, what are good numbers for these blocks? I remind you the rule that I mentioned before. That is, if a block uses values defined by other blocks, previously I showed you the statements, but here is the same. In this case, this block should be executed after this. And for example, this block, since it uses values defined by this and this block should be executed after this and this. So in general, since the blocks have the input on the left and the output on the right, the sequence is in general from left to right. So after this block, this could be number 20, this could be number 30, number 40, 50, and so on. Okay, I show you the basic way to change the block execution order, but imagine that if you have a page full of blocks, that way to change the numbers is quite boring. There are two ways to automatically, more or less automatically, change the number. You have to right-click the background of the page, select Calculate Block Execution Order, define the start value, for example 500, step 1, for example, and then manual assignment. Manual means that I define the sequence. So click OK. You see that the cursor change shape, becomes a cursor with 1, 2, 3. Now, every time we click a block, the system applies the next number. So it's even more convenient if you zoom out in order to have the global view of the blocks. And then click this. No, I click the background. Try again. The last was 508. Step 1. 511. 12, 13, this, and this. And then ask or right button of the mouse to finish this sequence. Well, let's see another typical use case. Let's imagine that we need of another block that must be executed between this and this. Between 1 and 501 and 503. Between these two numbers there is only 502, but 502 is already used. So we should change this to 504, but it is already used. Okay, it is a mess. So, but there is an easy way to make space between the numbers, maintaining the order. So look at here. Now we have this block, and after that this, okay, and so on. Now we can use again the Calculate Block Execution Order. For example, starting from 200, step 10. This time I don't select manual, so the result is this. All the numbers are modified in the same time, starting from 200, step 10, and the sequence is preserved. So this one, and after this, and so on. So now there is space between these two numbers. For example, 212, okay, and so on. So we strongly recommend the use of this function without the manual assignment. So when you define your strategy, you can place the block in the order you prefer. After that, right click and define the sequence. And sooner or later, after you placed a lot of blocks, I recommend you to, let's say, set a uniform space between numbers using this one. We recommend to leave 10 as a step in order to have something like 10, 20, 30, 40, 50, and so on, ready to allow to place a block between them. Well, so far we spoke about the execution order of the block of the same page, but a real application can't fit in a single page. A typical application has 10, 20, 30, 100 pages. So this is the good opportunity to see how to create new pages. Okay, it's not complicated as usual to do something regarding an item. Just right click somewhere there. So here is the way to create new pages. So we create other 2, 3 pages. New page, new page, new page. We can also give a name to the page. For example, we could have a page with all the inputs, rename a page with all the output, page for alarms, for example, and a page for cooling, heating. So I tell you once again that the number defines the order in the current page. In fact, if you place or also if you copy blocks in other pages, you see that the number restarts from 10. Also, if you copy and paste in this way, the system automatically gives the first free number. So the number defines the order of the block in the current page, and then the order, the execution order of the page in the project is from top to bottom as they appear here in the Solution Explorer. But in the moment we have the same issue of before, as the order of the blocks here sometimes is important, sometimes is critical, other times is not so important, is the same is for the pages. For example, doesn't make sense to define the status of cooling heating before to read the value of the temperature. Understand? So also the sequence of the page could be important, so that can be changed. The way to change the order is right-click, change page order. So we can move the input page at the beginning, output, okay, is already at the end, that's good. Cool heating after the alarms. So this is the ideal order. The first part of the program reads the input and then manages the alarm, because alarms probably use the status of digital and analog input. After that, we manage the devices because they use the value of temperature as well as the alarms. After that, they find the status of the output because it uses status defined in this page. Well, what I've done here is something very important. It is also written in the guidelines that I will show you in very soon, that is recommended to create one or more pages for each function or device. Okay, there is a slide with a summary of the most used or important requirements of the guidelines. In the DVD as well as in the KSA, you can find the complete and updated list of the guidelines. Well, one of the points is this one. Strategy pages create one or more pages for each function and device. One or more pages for the input, one or more pages for the alarms, one or more pages for the devices, and so on. So don't put like the project as it is done now, all the blocks in the same page or without any relationship between them. But give a good structure of the project. So since we have a page for the input and a page for the output, I take the opportunity to move the block of input and output. So I will move this, so copy, and paste, delete the other blocks. So in the input page, I read the analog input in this case, and so I can remove from here Probably this was the easiest way to do that. And the same for the output. Copy. Okay, also here. So here is a page with all the outputs. Remove from the original position. So in this strategy, we use a value of an input that is read in this page. We define the status of the output, and the output are physically defined in the page output. Okay, there is only one last remark regarding the block execution order, that is, you can't place two blocks with the same number. If you double click, it allows you to set here a number that is already present. It warns you with a message, attention that you can't use 2 times the same number. This because the system supposes that later on you change the number of the other block. But anyway, if you leave 2 blocks with the same number, when you compile, you will receive an error. So I repeat, the message is when you place down the strategy, place the block as they come in your mind, connect them in the right way, but later you have to take care of the number, else you may have a program with not ideal performance, that is with a slower reaction time. Okay, that's all for this topic. Thank you for watching this tutorial.